Hey guys, so in this first video, which I'm going to call Trig number 1, we're going to actually just discuss the concept of radians, because I think a lot of you are used to working with pi over 2 and pi over 6 and converting from radians to degrees, but I want to make sure you have a really deep understanding of what a radian is. Everything that we deal with in calculus when we talk about angles is exclusively done in radians. You will not see, I don't think I've seen anything done in degrees, and I took 6 of the last year's AP tests, and there was not one thing in degrees. So although this may be intense review for a lot of you, I think it's good for you to look through it and just get a good idea of what it means too, because our ultimate goal is to try to avoid some memorizing. So first thing what I want to do is I'm going to draw an angle up here, okay, and I'm just going to call it theta. You can see if you were to kind of guesstimate its measure, you'd say, oh, that's about, I don't know, 45 degrees, maybe 50, whatever. It doesn't really matter what its measure is. In a degree, most of you know that when you go all the way around a circle, you know that you go 360 degrees. So you know that a degree is a very, very small unit of measure. But there's other ways to measure angles in math, and in higher levels of math, basically pre-calc and beyond, and then in our higher levels of the sciences, we do the measurement of angles exclusively in radians. And what a radian is actually a very simple concept, and it actually, when you write it out, it actually comes from the root word of radius. And when you measure an angle in radians, what you do is you take this radius, and you're really telling me how many of those are in the intercepted arc. So you can see if I were to call this 1 radius, and even it doesn't really matter the units on it, you can see that right here, if I were to block that off and kind of stretch it out here, I'm a little under 1 radius unit that's being cut off by that angle. So if I were to go calculate that in radians, it'd be a little under 1. Well, I'm going to extend that thought a little bit farther here. Again, I'm going to draw full circle. And let's talk about this for a second. Most of you know that the circumference of a circle is 2 times pi times the radius. Little radius on there again. And that gives you the distance around the circle. Now let's talk about the measure of the arc that gets cut off, because when we're talking about radians, we're talking about the measure of the arc. And so you know that a full way around a circle is really 360 degrees. And I'm going to say, well, this radius is 1, because we're going to be talking about the unit circle. So I'm just going to leave this off here and assume it's 1. And this is where you've got that pre-calc idea of a full way around a circle is 2 pi. But keep in mind what that's really telling you. It's 2 pi radians. And really what that means is if you consider pi being about 3 or 3.14, like they have you think of in elementary school, 2 times about 3 is about 6. So what that's really telling you is if I take this radius unit, and even if I were to measure it out with some string, if I were to stretch it along here, I'd have about 1, about 2, about 3, about 4, about 5, oh, about 6 radii that stretch across the whole entire circle. And that's why we say that 360 degrees is 2 pi. Now, I'm going to even divide both sides by 2 here and take it a little farther. Well, that means that 100 degrees is really about pi radians. These are equal. Now, again, watch. Pi is about 3.14. So let's go across here. And again, I'm talking about the length of this radius, 1 unit. I've got about 1, 2, and maybe a little past 3. And so that's why we say that halfway around a circle is equivalent to pi radians. Now this is interesting because I know you've learned how to convert in that, you know, if I have 60 degrees, they teach you in Algebra 2 and pre-calculus, well, to convert that to radians, you multiply by pi over 180. But why does that work? Here's why right here. It's because these are equivalent. It's because if I divide both sides by 180, you'll notice I get 1. Really what I'm multiplying this by 1 or by a conversion factor. I'm going to really take it a little farther back here for you and talk about, you've done this before actually, you just didn't have it done in this context. So I'm going to erase this to give me a little more paper. You've done it in the context of converting between, let's just say, the metric system and the US system, and I'm going to say, well, we know that an inch is 2.54 centimeters. This is a conversion factor. They are equal. So you were taught in junior high, well, if you have 8 centimeters and you want to convert them to inches, you multiply by 1 inch over 2.54 centimeters. And you say, well, these cancel, and when I'm done, I'll have my answer in inches. And that's exactly what you're doing in trig. When you take 90 degrees and I say, well, what is that in radians? I need to convert. This is a conversion factor. And I need to have what I want to cancel on the bottom. Just like here, I have got centimeters on the bottom. Well, that means I need my degrees on the bottom. And pi radians is equivalent to 180 degrees, which is why you've probably memorized. But again, we're really trying to avoid all memorization possible. So I know you've probably memorized that 90 degrees is pi over 2. You maybe have even memorized how to convert. I really want you to understand what you're doing. You're changing its units of measure. Like here, going from centimeters to inches. Well, I want to go from degrees to radians. So I multiply by that conversion factor, and that leaves me with pi over 2. So that's kind of a deeper understanding of what a radian is. I'm going to keep this one on the bottom up here so again, so you can see it on this circle. What I'm telling you is that when you go 90 degrees, which we know, and right now I just told you that's the same as pi over 2. Instead of saying, well, 90 little 1 degree measurements around here, I'm changing its unit of measure to radians. And I'm telling you that this would be pi, about 3.14-ish, divided by 2. You know, I'm going to just estimate that and say it's about 3 over 2 radians, which is 1.5. Interesting, because look, when I take that radius length, looks like it takes about 1.5 of them to complete that intercepted arc. So now what I'd like to do is move forward a page here, see if it'll go. Here we go. And I'm going to talk about the entire unit circle, again with a radius of 1. These are all the key points that you need to know, but I don't want you using a note card because you can't on the AP exam. So I want you to kind of intuitively know what these are. Our main ones are found obviously right here at the corners. We can get these very easily. This is 0 radians, or if you want to picture me already have gone all the way around, I could think, well, it's 360 degrees, which I just told you is 2 pi. And again, well, that means halfway around is pi. But again, notice what pi, what's that? Well, what that's telling you again is pi is about 3.14, and it takes about 1, 2, 3-ish of those radii units to stretch across there. Well, this is 0 and this is pi. Obviously, this is halfway, so pi over 2. So I've got 0, I've got 1 pi over 2, I've got 2 pi over 2, I've got down here 3 pi over 2. So those are really easy ones to remember. Now, what I'd like to do is give you a little way to remember the other ones going around. We generally, in calculus, we generally kind of get locked in here in the first quadrant. But let's go get our main angles in radians. Right here we've got the 30 degree. And remember what I said, we're going to convert that to radians. So pi over 180 degrees. That's where that pi over 6 comes from. I'm going to put that right here. Now, here's the deal. I don't want to keep doing that all the way around there. That'd be a pain in the butt. So what I'm going to do is picture that as being 1/6 pi. What that means is every 30 degree angle increment, I bump it up by 1/6 pi. Now watch me do that. I'm going to ignore these ones in the middle here because those are halfway between, those are my 45 degree cuts. So I'm going to ignore those. Draw them in, but then I'm drawing them in so I can avoid them. All right? So the other ones on here, I've got my 30 degree, and then this one will be 60 degrees. And then 90 degrees, and then, but again, we don't like degrees, and we will not use them beyond today. So, clicking along here pretty quick, Let's talk about this as being 1/6 pi, which is 30 degrees. Well, then the next 30 degrees would be 2/6 pi. Well, that's pi over 3, which you might have memorized, but we don't want to memorize. And then up at the top here, we'd have 3/6 pi, which reduces to pi over 2, which means this one's going to be 4/6 pi. Watch what I'm doing again. 1/6, 2/6, 3/6, 4/6. We reduce that to 2 pi over 3. Then this would be 5/6 pi. And look, no coincidence, 6/6 pi, bam, matches, looks good. This would be 7/6 pi, ignore that one. This would be 8/6 pi. Well, I'm going to stop and reduce that, which is 4/3 pi. We call it 4 pi over 3. No shocker here that this is 9/6 pi, which I already kind of knew. So then over here, 10/6 pi, which I'm going to reduce to 5/3. And lastly, 11/6 pi. So it's a really easy way to get you around the unit circle with really not memorizing. Actually, if all you know is that 30 degrees is pi over 6, we're pretty set to get all those angles. Now let's talk about the 45-degree increments right here. All right, well, 45 degrees. I already memorized it, that it's pi over 4, but let's do a conversion factor, and this is 1/4. Well, every one is pi over 4. I'm starting to talk fast because I run out of time at 15 minutes. I want to get around here before my time runs out. So 1/4 pi, or pi over 4. What that means is every 45-degree increment will bump that up, 1/4 pi. Well, here's my first one at 45, my next one at 90. Well, it'll go from 1/4 to 2/4. Well, should better match. So I've got 1/4 pi, 2/4 pi. My next one right here would be 3/4 pi. No shocker that my next 45 degree is 4/4 pi. Notice I've just gotten that pi at 180 degrees, I think about 6 different ways here. So I've got, back to the beginning, I've got 1/4, I've got 2/4 pi, I've got 3/4 pi, I've got 4/4 pi, which would make this one 5/4 pi. And no shocker, 6/4 pi, again, reduces to what I've already got. This would be 7/4 pi, and back to the beginning, 8/4 pi. So really quick way to get around that unit circle. And you should kind of practice that because it's a good skill to have without, notice I did not memorize, I didn't need a calculator, and I didn't need to convert. I simply understood that every 30 degrees on my unit circle was 1/6 pi, or pi over 6. Watch me do it very quickly here right now. Here I go. All right? I know this is 0, which is 2 pi. Every 30 degrees, 1/6 pi, 2/6 pi, which is 1/3, 3/6 pi, which is 1/2. Next one, 4/6 pi, which is 2/3. Where am I? Oops, I wrote it on the wrong one. Sorry. 4/6 pi, which is 2/3. 5/6 pi, 6/6 pi, 7/6 pi. It's making me hungry. All right, next one, 8/6 pi would be right here, or 4 pi over 3. 9/6 pi, which is 3 pi over 2. 10/6, which is 5 pi over 3. And 11/6. Done. Well, let's do the other ones then. Remember, 45 degrees is pi over 4, or 1/4 pi. 2/4 pi, 3/4 pi, 4/4 pi, 5/4 pi, 6/4, 7/4, and 8/4. And I have just done that without memorizing anything. Excellent skill to have. So what I'd like you to do is maybe practice that for a little bit, and I'm going to save this, and I'll have another one that I titled Trig Circle, Unit Circle number 2.